Hi everyone, welcome back. In today's lesson, we're going to be looking at the concept of noise, specifically Perlin noise. We're going to compare this with randomness, and we'll see how noise can help us create some more structured variations within our programs. Today, we're also going to introduce a library called dat.GUI, and that's going to allow us to start to create some controls for ourselves as we develop generative artwork so that we can tweak variables using an interface instead of having to change values in the code. So let's dive right in. Okay, so we're going to start just like every example this semester. We're going to start with our P5.js blank and make a remixed version of this. One way you can find that sketch, other than the link I've shared with you, you can also just search for it on glitch.com and it'll come up. So let's remix this project and start a new sketch. Okay, so let's call this one random line. So in this first lesson, we're just going to introduce the concept of noise, and we're going to contrast it with just pure randomness. Comparing random to noise. And we're going to do so by drawing a line. Okay, let's see the output of our program, and we don't need this circle. Let's get rid of it. We'll use a black background for this example. Just setting some parameters here, a white stroke and no fill. Okay, so let's begin by drawing a line. Okay, very simple. I'm going to draw a line that's going to run across the canvas here. So I'm going to start from 0 to the middle, all the way to width. Okay. All right, so a simple line. Now, if we wanted to make this line maybe more interesting, or just to demonstrate the concept today, I'm going to be adding some randomness to it, and we'll see how random behaves, and then afterwards we're going to compare it with noise, and you'll be able to see a really big difference between the two. So we're going to add some randomness to the line, which means we need to draw this line a little bit differently. We're going to take the long way. Right now, we can't control how the line appears at all because it's just a straight line. So instead, we're going to draw it 1 pixel at a time so that we can interfere with the position of each pixel as we draw this line. So if we wanted to draw the same line 1 pixel at a time, we would use a for loop. We could count from 0 to width in increments of 1, right? And then each point of the way, each step of the way, we could draw a point. That's our line. Same difference, except now I'm drawing it 1 point at a time. Now, having done this, we have an opportunity to introduce some randomness into the process, just to mix things up a little bit. So we're going to replace this here, the y coordinate. We're going to replace it with a variable. Okay, we're going to call that y. So the same thing here. But now we can introduce some randomness here. So for example, we could say random. So random always returns a number between 0 and 1 if we don't give it any parameters. And let's say we multiply this, right, by even the whole height of our window. Now we can see we've got lots of randomness. Okay? So the positions, the y coordinates of the pixels are purely random. And we can pause this and we see the layout is completely random. In fact, let's make the stroke weight a little bigger because this might be hard to see on some screens. Okay. So completely random. All right, so I'm going to make a few more tweaks to this just so we can start to illustrate our point for today. So first of all, I'm going to move the origin to the middle of the window, and then we're going to map the random number that we get in a range that's going to be centered around this 0 point here. So I'm going to translate the origin down so that now the origin is over here. Okay. And when we get our random number here, let's just call it R. We're going to grab a random number, and then we're going to map this number. So we're going to map R, which is between 0 and 1. We're going to map it to a range that we're interested in. Okay, so let's say, minus 100 to 100. So now we are able to better define this this range for our random line distribution. Now we could make it very small. Right? So now this is our random line. Well, we can make it larger. Now this this height here, this gap, this is a good thing. This is a good parameter to turn into a variable. This might be something I want to tweak, right? Minus 100 to 100. So let's call that the size. Okay. I'm going to call it size 100. And then here, instead of minus 100, I'm going to put size and size. So that if I want to play with it and try different values, I only have one place where I can change it. Okay. Now this is really hard to tell this is actually a line because we're just drawing disconnected points. Okay, so this is why it looks kind of this bunch of flies or a bunch of bees in the summer. So rather than drawing disconnected point, let's see if we can connect the dots to see what our random line actually looks like. So an easy way that we can do this is we can use the shape function in P5.js. So to draw a shape, we're going to do begin shape before a for loop. And at the end of the for loop, we're going to put end shape. And inside the for loop, instead of drawing a point, instead we're going to draw what's called a vertex. So a vertex is a point inside a shape. So for example, a square has 4 vertices, right? So 1 vertex per corner. Here we're going to draw a long line with a bunch of vertices. So now it's going to take all the points that we're drawing and connect them together as a shape. It's going to be an open shape. So if if we put closed in here, it would connect it. Oh, just close. It would connect it back to the beginning, which we don't need to do that here in this case. We're just drawing this open shape. So now we can see this is really like our line that we started with, except it's being randomly modulated, right? We're changing the y coordinate to be random instead of just following a line like we used to before. Okay. So this randomness we can see is interesting because we can generate random numbers, but it also has a pretty serious drawback, which is it's kind of too random, right? It's really difficult to tame the randomness because it is all over the place, right? We could, for example, we could try to make the random a little bit less crazy. We could say, let's start with a random number here, right? So just a single random number in every frame. So that's just going to move our line up and down. And then as we draw it, we could say, let's add a little bit to this random number as we go. So maybe a really small amount. So now we're starting with a random number, and then we're just kind of moving up or down from that number over time. So this is what this line is doing. It's a little bit hard to see the effect here because I have just this we can tweak this number. If we can make it really, really small or really large, we'll see what happens. So this is not changing very much. If we make this number bigger, it means the step, right? The step in between each line is in between each y variable is going to be larger. Let's make the size smaller. All right. Okay, so this is another quantity here that we might want to tweak. Okay, this is 0.1. This is the range of motion of our randomness, or I like to think of it as like the resolution of the randomness. If it's really small, right, we have a very fine resolution, and if it's a big number, we have this kind of coarse resolution of movement. So this is another thing that would benefit from being a variable. So let's call this 0.1, and then down here we can say minus res and res. So now we have these two parameters that we can tweak to try to understand what our program is doing. We have the size, which is the height of this range here, and then we have the resolution, which is how much our randomness is being moved up and down. So before we move on to talking about noise, we're gonna introduce a new concept here, which is going to be adding an interface to our program, so that if we want to change these values, we don't have to go in the code and just keep changing them. Even though in P5.js it's kind of nice that it automatically updates, right? We don't have to rerun the program or anything like this. It's still not very intuitive to do, and we can only change one value at a time, and in increments we have to edit it. It's not very user friendly. So what we're going to do is we're going to create some sliders, some interface control for ourselves to explore what our program is doing. And we're going to use a library for doing this called dat.GUI. So this is the GitHub page for this library. You'll remember from an earlier video I mentioned we have included, if I open the HTML for our project here, we already have included dat.GUI as part of the scripts that we're bringing in. Okay, so we don't have to do anything new. It's part of the blank template. So it's already available. There's a little bit of information on how to use it. This is not a library that's designed for P5.js specifically. It's just a general JavaScript library. But all the JavaScript libraries usually play pretty well with P5.js. It has a really great tutorial, which unfortunately is offline right now. Something has happened there, but I will provide in the description, the video description, a link to an archived version of that tutorial if you want to have a look at it and refer to it. We're going to be using this library throughout our examples this semester. So we're going to give, we're going to sort of figure out the features as we go. So let's do a simple example of how to use dat.GUI. So the first thing we do is we create a variable. We're going to call it the GUI. And GUI, by the way, stands for Graphical User Interface. And then in setup, we're going to create our GUI. So we'll say new. So this is similar to when we were programming in Java. We're about to create a new object. And the name of that object is dat.GUI. This is coming from the library which we've imported in the index.html file. Okay. Now the way that the GUI works is that we're going to pass it an object that has some variables inside of it, and we're going to tell it which variables we're interested in modifying. We're going to give it the range of values we want each variable to have, and then the GUI, you see, just by having created that object, is going to give us some controls that we can use to change these variables on the fly. If you've used in processing, there's a library called control P5 that's very similar to this in spirit. So right now we don't have any controls because we haven't added any variables that the user interface can change. So a new concept here that we're going to introduce as well is this idea of objects in JavaScript. Now this is a little bit different from objects in Java, because when we created objects in Java, we had to use the class for the class syntax. We had to define a template. Then we could instantiate objects from that class. We can also do this in JavaScript, and we'll have examples of this down the road. But objects in JavaScript can also be much simpler. They can just be collections of variables packaged together that can become an object. So for example, I'm going to create an object called settings. That object is going to contain all the variables we want to be able to tweak inside our sketch. So things like size and res. And the syntax to define objects in JavaScript, like on the fly, is going to be using the curly brackets. So I'm going to say open and close curly brackets. So now settings is going to be an object. And inside the curly brackets, we can enumerate different key value pairs for this object. So the key is essentially, it's the variable name, and then the value is going to be the value for this variable. So for example, we could say settings will have a size setting. So that's the key, that's the name of the variable. And then we're going to use the colon and we'll put the value. Okay? So we'll say size 15. And then we separate each of the variables using a comma. So we'll say size, and then we'll say res 0.1. I'm going to delete those. All right, so notice I broke my sketch because I have not updated anything down here, but that's fine. We'll get to that in a second. So now we have this object called settings, and inside settings we have a variable called size, and we have a variable called res. Okay? So for instance, we could do, settings.size, right? We could refer to it like this, or we could do settings.res. So setting.size will be 15, setting.res will be 0.01. Okay, so let's add some sliders so we can control these values. Well, actually, first, let's fix our program because it's annoying to have a broken program here. So now that I've moved these inside this setting objects, I just have to refer to them here in my code accordingly. So instead of minus res and res, I'm going to say minus settings.res and setting.res, settings, plural. And here I'm going to say settings.size, settings.size. And we're back. Okay. Now, because we've put these into an object, now we can tell dat.GUI that we want to be able to affect these variables using some sliders. And that is very easy to do. We're going to say GUI.add. We'll say which object contains the variables. That's the settings object. Then we're going to give the name of one of those settings we want to affect, or one of those variables, right? By the way, it doesn't have to be called settings. I just decided to call the variable that. It could be called anything. But settings just makes sense to me because this is where all of our parameters for our program, we're going to be storing them in there. And then we'll say, okay, size, right? If I don't do anything, see, size appears here, and now we can change it as just a number box, right? We could enter a number directly if we wanted to. That's the default. It's kind of nice. But I'd like to have a slider. So if I want a slider, I'm just going to specify a range. So let's say we're going to let size go from 5 to 200. So now magically, dat.GUI has figured out, okay, there's a range, so I want this value to be a slider. So now I can slide size from 5 to 200 in my code. And that goes into settings, changes the size variable. And in my code here, I'm using settings.size whenever I want to refer to that value. We can do the same thing with the other one, the res. So res has a different range of values. Let's say we wanted to go from, really small to a little bit bigger. So now we have control over this variable as well. So moving on, we'll see down the road with the GUI, we can add all kinds of parameters to our program. We can add text boxes. We can add, color boxes if we want to have control over the colors. We'll do more examples down the road. This is just introducing the concept. And we're going to take advantage of this quite a bit because the examples we're building, these generative examples, they rely a lot on this idea of having, parametric design, where we're going to create variables that are going to control the outcome of the program. And having this manual control over these variables is going to be very handy for us as we develop examples and we try to understand what they're doing and come up with interesting results. Okay, so this is random, and we see we can kind of tame the randomness a little bit, right? We can say start with a random number, or we could just go back to what we had before. Now that we've created this this variable here, I can expand the size, right? This is just pure randomness, right? No, no attempt to try to control it. So let's contrast this with the concept of noise. Now, there's lots of different kinds of noise, but today we're looking specifically at Perlin Noise. That's the one that's implemented inside P5.js. So what noise does is it gives us access to random numbers, but that follow this kind of natural distribution. Okay? So it's got more of a smoothness to it that in turn allows us to create less crazy all over the place randomness. So it's still going to be unpredictable, but it's going to be a little bit more natural. Okay? So let's give an example of how we would use noise instead of random. So noise is also going to vary between 0 and 1. Okay? Now the difference is that in the noise, we have to give it a parameter, which is where we're going to be sampling the noise value. So it's going to become clear in a second when we render it. I'm just going to put a number here right now so we get a value. Okay, so it's now I put in the number 1, so I'm always going to get the same number out of noise. One way I like to think of Perlin Noise is like a mountain range. It's like a landscape. And depending on which value you put in the parameter, you're sort of picking different heights along the landscape, along the mountain peaks. So for example, if we used, instead of always the same number, we're going to put in our variable x as the entry point into noise. Now we're sort of sampling different values along this landscape, and then using those as our random numbers. Okay? So you might have noticed one thing already is that even though I don't have no loop, right? This has stopped being all crazy and just changing. This is now a fixed value, which means Perlin noise is random, but it's also predictable. So when you first start the program, the noise is created. The noise function has what's called a seed. And when you put in that seed, the random values that you get afterwards are going to be consistent. So when I say noise with 1 or 2 or 0, it's going to be random every time I run the program, but for the duration of the program, it's always going to be the same random value. So that's why it appears static now. So because I'm always sampling in the same place in this kind of noise landscape. Now we could also take advantage of res here. So right now I'm doing these pretty big jumps by increments of 1 across this noise landscape. So it actually looks a lot like the random we had before. So what we can do is we're going to scale this down a bit. We're going to multiply x by res. And that's going to make x smaller, basically. And now we can see this starts to look a lot more like a landscape. And so if I change this number here, we're almost flat, but then I can increase it slightly. Let's make the peaks a little bit bigger. I can increase it slightly, right? And now we can see we're moving across this noise space. So what the res is doing is it's simply just dividing x, right? Making it smaller, which means we're kind of moving slower across that random noise space. So that's what I mean also by more natural. You see how random was all over the place, right? Perlin noise has these kinds of peaks and valleys. These are random by nature, but you never, from one value to the next in the series, you never get a huge jump. It's always going to be this natural up and down motion. That's still unpredictable, right? We can never tell where the next number in the sequence is going to go, but it has this kind of more natural progression to it versus random. That's just like you have no clue what the next number is going to be in relationship to the previous number in the series. It's just pure randomness. So in that way, noise becomes a lot more useful to create variations in the programs where you have a little bit more control over how the randomness is being shaped. Another interesting thing we can do with Perlin noise is because it's essentially an infinite space, right? This mountain range we're sampling goes on to infinity, right? If we add an offset into the space, right, we can create animations. So for example, instead of just taking x, right, as the value that I'm using to pick a number in the space, I'm going to add a constant offset to this. Let's say my mouse Y cursor position. And you'll see what happens when I do this. I'm going to say mouse Y plus X. So now mouse Y becomes an offset. And then I can kind of scroll through the noise space. Because again, the noise is random, but it doesn't change for the duration of the program. It has a seed at the beginning that then predicts what's going to happen to it as the program runs. So we can essentially navigate this space and then go and sample in individual values to get our randomness. This is what the noise function is doing. So ways that we're taming this, right, is we're using this res or resolution variable to sort of divide things a little bit. If this number was really high, then we would be jumping so far ahead from one peak to the next that it would essentially be random, right? The result would be randomness. By dividing it, we move across the space much more slowly, and that gives us this smoother up and down value. And the lines are moving because mouse Y here is adding a constant offset into the noise space. We could also replace mouse Y by something like frame count. Remember, frame count is just a number that goes up by 1 in every frame. So if I add frame count now, my mouse is not doing anything. Now we're basically scrolling through, right? Every time we run a new frame, we're starting a little further along this noise space here. And then we're using X, right, to kind of go and sample points down the line. And then we're using res to divide these two numbers here so that we're not moving too fast and getting something that looks a lot like randomness. Let's increase, the res all the way up to 1 just so we can see what happens I'm going to make the lines bigger just so we can see what happens. Like as I increase the res, you see we're going to jump really far across the peaks, and then when you get too far up, this basically becomes indistinguishable from randomness because we no longer have the continuity, the smoothness happening. What we do get though from noise, even as I'm jumping across here, is it is consistent from frame to frame. Okay? So we get randomness, but it's not always changing from frame to frame. It's sort of set for the duration of the program. And this space will go on to infinity, right? We can just continue to sample it. Frame count can continue to increase. There is no end to it because it's a mathematically generated space. All right. So Perlin Noise is a lot more useful with small values here, right? When we divide the input into the noise sampling so that we don't jump too much from one noise value to the next. So we can retain these smooth curves. And that gives us some unpredictability, right? If we look at the edge of the window here, I don't know where it's going to go next. It's going up and down, right? That's random, but it's also got that smoothness to it. Okay. So to recap briefly, right, we've done a couple of things in this example. So first we started with just a line, right? Then we added some randomness to the line just to show how difficult to tame random can be, right? It's just pure noise, not to confuse things. It's just completely unpredictable, which can be interesting sometimes, but too much unpredictability can also result in a bit of a mess at times. So now we've introduced this new concept we can use called noise as an alternative to randomness, where it's still unpredictable, but it's got much more of a natural progression to it. So it's more controlled. It's not going to jump all over the place. From one value to the next, we have some continuity. Also, from one frame to the next, if we sample the same noise point, right? If we give the same input value to the noise function, we're going to get the same number back. So the way that we create random numbers is by moving through this space, by increasing the input that we're putting into the noise function. So we can do this using frame count or whatever other ways we can come up with. That allows us to kind of keep moving through that space and then generate new random values as we go. And then the last thing we talked about is we added this user interface to our program. And I encourage you to play around with this a little bit, try different values, try to see if you could maybe come up with something else that could become a parameter and then add it to the GUI over here. The user interface idea is something we're going to start to build into most of our sketches, just for convenience, but also to make it easier to explore and wrap our heads around what exactly it is that our code is doing. The way we're going to do this term is we're going to use dat.GUI, right, which is a library that creates this user interface here. There's lots of other JavaScript libraries for doing user interfaces. I chose dat.GUI because it's very easy to use, and the controls are varied and mostly easy to use. I forgot my semicolon there. Let's put it in. Yeah, so the way dat.GUI works is we create a JavaScript object, which using this syntax. So settings is an object, and inside settings we have two variables. We have size and res, and then we can add this object to our GUI. We tell the interface what are the names of the variables we want to change, and depending on the parameters we put here, it's going to decide what kind of controls it gives us. So if we put nothing, the default is just a number box. If we put a range, it becomes a slider. And we'll see there's like other types of things we can do, like drop down menus. It can get pretty involved. As we build more complex programs, we're going to get to know this library a little bit better. But for now, we'll just keep it very basic for this example. So now that we know a little bit about noise, in our next video, we're going to talk about maybe a more concrete, interesting application of noise. So we're going to use noise to generate random movement, but movement that's going to have some natural elements to it. We're also going to talk about creating movement in 2 dimensions. So we're going to look at sampling this noise landscape in different places to get 2 different values moving, right, without a relationship between them, but both controlled by the same noise source. So I'll see you in the next video.